Greater learners, welcome to the session. My name is Mahapi, and I'm working as a senior advisor for mathematics in Mangaung Metropolitan Education District. So today we're going to discuss two-dimensional problems. Two-dimensional problems. In short, we call them 2D problems. But basically it's two-dimensional problems. And what is of importance in two-dimensional problems? Think of the situation. The horizontal surface, the floor, horizontal surface. Look at the wall, a vertical surface. Horizontal, vertical. The two constitute two dimensions. Two dimensions. Horizontal, the floor, the wall is vertical. So that constitutes one. The horizontal, vertical constitute two-dimensional problems. That is basically the type of problems that we are going to discuss. Two-dimensional mainly refers to, if I were to make an example, if one climbs up the roof of the house, then you are there at the ground, you are climbing up. So there is this horizontal surface, there is this vertical surface that then constitute two-dimensional problems. Two important terminologies that one should take note of. The angle of depression. The angle of depression. This is an angle in horizontal line from an observer. Observer, horizontal line from an observer, and the line of sight of the object that I'm looking at. And then it is formed when the observer looks downwards. Depression, the observer looks downwards. So this angle becomes let me make an example of a diagram. Here is an observer at point A, looking at an object here. So the angle of depression, looking downwards, this will be the angle of depression from the observer downwards. That's what you call the angle of depression. If we talk of the angle of elevation, you have an observer standing here at point T. Now the observer looks up. With the angle of elevation, you've got the observer looking upwards. Whereas in the angle of depression, we said the observer is looking downwards. So if the observer is standing in this position, horizontal surface to the observer, now if the observer looks upwards, now we have the angle of elevation being formed there. So these are the two important concepts: angle of depression, angle of elevation. With angle of depression, horizontal to the observer's eyes, the observer looks downwards. You look downwards, then an angle of depression is formed. But if you look upwards, we talk of the angle of elevation. Good. Let me make an example. AB represents a pole. AB represents a lamp pole with height 25 meters. Two cables from the top of the pole are anchored at C and D. Two cables from the top of the pole are anchored at C and D. Are anchored at C and D. From A, the angle of depression of C and D in the same horizontal line is 75 and 67 degrees respectively. angles of depression of C and D in the same horizontal line as B in the same horizontal line as B are 75 degrees and 67 degrees respectively. Now the question says calculate the distance between the two anchor points. This information I'm going to try and represent it with the aid of a diagram. You have AB, and remember AB, A, B. It said that AB represents a lamp pole. This is the horizontal surface. You've got at some point there you've got C, and then here you've got D. The angle of depression from an observer at point A. Two cables are anchored at C and D. From observer at point 8, we have anchoring here to point C and to point D. But remember, an observer at point A, this view will be parallel to the floor. View is parallel to the floor. So the angle of depression of C and D in the same horizontal plane as B are 75 and 67. 75 degrees becomes this one. This is the angle of depression from A to C, the angle of depression. Depression, you look downwards. So this angle is given as 75 degrees. And the angle of depression of D, the angle of depression to D is 67 degrees. This angle here, alone here, becomes 67 degrees. Thank you. Remember at the beginning, you were given that AB represents a lamp pole with a height of 25 meters, meaning the height here becomes 25 meters. If we talk of height, this angle here must be 90 degrees. This angle here must be 90 degrees. These are the two-dimensional problems. I'm trying to translate this math statement and represent it in terms of a diagram. AB represents a vertical lamp pole. From an observer at point A, the angle of depression of C is 75 degrees and the angle of depression of D becomes 67 degrees. Now, the question reads, calculate the distance between the two anchors. Remember, we have two anchors at point C and at point D. We want to calculate the distance between the two anchors, the distance between C and D, because C and D are the two cables that are anchoring from point A. Now, let's try and work out the solution. If you look at the diagram, you then ask yourself, remember I said from the end observer horizontal to the parallel to the horizontal surface. An observer's view here parallel to the horizontal surface. This line must then be parallel to this one. We need to know that. And this angle is given as 67 degrees. This whole angle is given as 75. Remember, because they are parallel, if this angle is 90, even this angle as a whole must be 90 degrees. our question, we want to calculate the length of CD. The question reads, calculate the distance CD between the two anchors. Calculate the distance between the two anchors. Here is CD. How can you calculate CD? Great test. How can you calculate CD? So it will be easy for us if we can work out the magnitude of this angle. Once we have this angle, we will then be able to calculate the length of base C. Let's start. Remember, this angle as a whole is 90 degrees. So this angle alone, this one, it will be 90 degrees because it's 90. This one is 75. It will be 90 degrees minus 75. You need to have a calculator because we are going to use log calculator a lot. It will be 90 degrees minus 75 degrees. So this angle will then be 15 degrees. This angle will be 15 degrees. Let me call it angle BAC. BAC, that angle is equals to 15 degrees. You remember how we got it? The two angles. The whole angle should be 90 degrees. So if this angle is 75, this remaining portion will then constitute 15 degrees. Now, how can we calculate this side, BC? Relative to 15 degrees, BC becomes the opposite. AB becomes the adjacent. So, because you think of the trig ratios that have opposite and adjacent, and that trig ratio will be a tangent. Now you calculate the tangent of 15 degrees. Tangent of 15 degrees, opposite over adjacent, BC over 25. Remember, now you take out a calculator, you 15, you multiply by the tangent of, let me start afresh. To determine the length of BC, you multiply both sides by 25. It's 25 over 1. This 25 will cancel that one. You'll be left with BC. But what you do on the right, you also do on the left. If you multiply by 25, even on this side, you multiply by 25. So we're going to say 25 multiplied by the tangent of 15. 25 multiplied by the tangent of 15. Then let's check the answer. The answer then gives us 6,7. 6,7 meters, because the distance is given in meters. 6,7 meters. This length BC will then be 6,7 meters. Why do I say meters? I said height is expressed in meters. This height is in meters. So all this other length in this problem will be expressed in terms of meters. Now we have BC being 6,7 meters this side. You write it down. This is 6,7. Remember the question. The question wants us to calculate the distance CD. We want to calculate the distance CD. We want to calculate the distance CD. We still don't have CD. So how can we get to CD? Think of your trig ratios. Thank you. Let's check. Remember, if we were to split this angle, work this angle out. If this angle as a whole from here is 75, this angle is given as 75 degrees. So if that angle is 75, this one alone is 67. So the remaining angle, angle CAD, will then be equal to 75 degrees if you subtract 67. And 75 minus 67, 75 minus 67. That angle will then be 8 degrees. Now you know sum of angles in a triangle. Sum of angles in a triangle. In this triangle, ABD, this angle alone, this one, angle BAD. We said CAD is equals to 8 degrees. Angle BAD will be equal to 5 BAD will be 15 plus 80 degrees, and 15 plus 8 will give you 23 degrees. So if you have this angle as 23 degrees, the whole angle as 23 degrees, you can work out the length of BD. You can work out the length of BD. How can we work it out? Check. We have this angle as 23 degrees. Now we calculate the tangent of 23 degrees. The tangent will be opposite. Opposite will be the whole BD, because you're taking off this bigger angle now, 23. The opposite will be BD over. Adjacent will still be 25. Like we did in this step, you multiply throughout by LCD, and our LCD will be 25. If you multiply this side by 25 over 1, this 25 cancels 25, you are left with BD. But remember the golden rule in mathematics. Remember the golden rule. What you do on the left, you also do on the right. So if you multiply this side by 25, even this left-hand side, you multiply by 25. Now, let's say 25 multiplied by tangent of 23. 25 multiplied by the tangent of 23 degrees. Our answer then gives us 10,6 meters. Thank you. This whole length, as it is, this whole length BD is 10,6 meters. Remember the question. The question wanted you to calculate CD. So from our arithmetic, if this whole length is 10, this alone is 6, what will be this one? This CD will then be, this whole length CD will be equal to this whole length, which is 10,6 meters, minus this one, 6,7. 6,7. Therefore, CD, take out a calculator, determine the difference. 10,6, you subtract 6.7, then your answer will be equal to 3,9 meters. That is the distance between the two anchors. The first anchor was at C, the other anchor at D. Anchor at C, anchor at D. So ultimately, CD will be equal to 3,9 meters. These are called two-dimensional problems. Why do you call them the two-dimensional? Because you top up the horizontal and the vertical surface and then try to represent the information diagrammatically, you end up with something like this. Thank you. Some more examples. Let me clean the board and then we continue with more examples relating to 2D problems. Thank you. And one thing that you should notice that this type of problems, it takes lots and lots of writing. So let me start with this one. In the sketch below, triangle MNP, triangle NFP is drawn, having right angle at N. Triangle MNP is drawn having a right angle at N. MN is 15 units. 15 units. A is the midpoint of Pn. A is the midpoint of Pn. A is the midpoint of Pn. Angle AMN is equal to 21 degrees. Angle AMN, this angle is equal to 21 degrees. Let me try and represent the information in the form of a diagram. Triangle MNP, strong. Triangle MNP, you've got M, you've got N, you've got P. It's triangle MNP is drawn having a right angle at N. What is a right angle? Once you talk of a right angle, we know that the size or the magnitude of that angle is 90 degrees. The right angle is nothing else but a 90-degree angle. So this symbol here shows that this angle N is equal to 90 degrees. Good. MN is 15 units. Where is MN? MN is given as 15 units. Where is MN is 15 units? A is the midpoint of Pn. Somewhere here on Pn, you have point A, such that AP is equals to AN. So A becomes the midpoint. Then let's draw this angle here. They joined AM, so that we have angle AMN. Angle AMN is 21 degrees. AMN, this angle is 21 degrees. Thank you. The first question then reads, calculate the first one, AN. Where is AN? AN, this side, AL. Second, we want to calculate the angle, PMN. What is angle PMN? PMN, this angle as a whole. Lastly, let's calculate MP. Where is MP? MP, this side. Thank you. Here is the question. Let's start working out the solution. Try to tell learners, it's important for you to read with understanding. And whatever you read here must relate to the diagram. Triangle MNP is drawn having a right angle at N. Here is right angle at N. Triangle MNP having a right angle at N. MN is 15. Here is MN. You can see it's 15 units. A is the midpoint. If A is the midpoint, it means PA is equal to AN. The two sides should be equal. If this one is 5 units, that one will also be 5 units. They are equal. And angle AMN is 21 degrees. The first question wants us to calculate AN. Let's calculate AN. We start. First, look at what you have. Look at the given information. What is given? We have this 21 degrees. We have this side. Now think of the trig ratios. Which trig ratio will include 21 degrees, 15 degrees, and AN? So, with reference to 21 degrees, AN becomes the opposite. This AM becomes adjacent. Which trig ratio has the ratio opposite over adjacent? Then becomes tangent. To answer the first one, we say the tangent of 21 degrees will be equals to AN over 50. AN over 15 units. Tangent, by definition, look at this triangle. Tangent is opposite over adjacent. This is a 90 degrees. Tangent is opposite over adjacent. AN over 15 degrees. Now to solve AN, multiply by LCD. Our LCD is 15 degrees. It's 15. I'm sorry, it's 15. So what do? You multiply by 15. It's AN over 15. Here we've got the tangent of 21 degrees. If you multiply this side by 15, it's 15 over 1. What you do on the right, you also do on the left. This side you multiply by 50. Let's check. 15 will cancel 15. You are only left with AN. Now you take out a calculator. 15 multiplied by the tangent of 21. Let's check. 15 multiplied by the tangent of 21. Let's check the answer. 5,76. Correct to 2 decimal places. 5,76 units. That is the length of AN. The first AN has been solved. We've got here 5,76. The first question is answered. And after answering the first question, let's go back. Remember, from the statement, it was given that A is the midpoint of PN. A is the midpoint. If this is 5,76, even AP is going to be 5,76 from the given statements earlier. So the whole length PN will be twice that. Thank you. 5. The second one. Calculate angle PMN. Angle PMN. We want to calculate this whole angle here. What do we have? Check what we have. Number one, you have MN is 15 degrees. You have this side. What is this side? It's 5,6 and 5,6. Add the two sides. PN is equals to what? Let's check. 5,76 plus 5,76. Let's check the letter of PA. Add the two. If you add the two, let's check our answer. 5,76. 11,52. So we've got PNS, the length of PNS 11,52. Correct 2 decimal places. So this whole length is 11,52. To calculate this angle PMN, you have to calculate the tangent thereof. Check the tangent of PMN. Angle PMN. The tangent of angle PMN, the whole angle, will be this side. And remember, this side as a whole, we agreed that it's 11,52. It will be opposite over adjacent. Let's check. 11,52 over. What is the adjacent side? Adjacent will be 50. Therefore, let's work out. Remember, in your calculator, to work out an angle, you go first to shift. Take your calculator. You take out your calculator, you go to shift, and then you press tangent. You'll see it will be tan exponent -1. Then you enter the ratio. 11,52 over 15. And then you close the bracket, and then you say equality sign. Our angle will be 37.52. Our angle will be 37,52 degrees. So this entire angle here, we have calculated this angle. This whole angle is 37,52. 37,52 degrees. So we are now left with the last one. And in the last question, they want you to calculate the length of MP. Where is MP? Here is MP. Here is MP. How can you calculate MP? We can use the trig ratios. You can use the Pythagoras theorem. Choice is yours. Which method will be easier? Remember the condition for using Pythagoras theorem. We only use Pythagoras theorem if you have two sides. You have this side, you know the side, and you know the other side. This is the only side that is unknown. Then you can work out the length of the remaining side by using Pythagoras theorem. Or alternatively, because MP is a hypotenuse, is an angle, is a side opposite to 90 degrees. It's hypotenuse. So to calculate hypotenuse, you can use the cosine or you can use the sine. Any of those three ratios will work out fine. I've given you three options. Can use sine, can use cos, you can even use the Pythagoras theorem. Fine, thank you. Let's start with the length of MP. To determine MP, let me use the cos, the sine, or anyone. Sine of 37,52 degrees is equal to the sine of the square opposite. This opposite you said is 11,52 over this side is MP, which is exactly the side that you want to calculate. So cross multiply and work out the length of NP. Therefore, MP will be equal to 11,52. You divide by the sine of 37,52 degrees. Then you take out your calculator, you work out the answer. I've got my calculator here. I work out, I press a sign. No, I don't press sign, I'm sorry. It's fraction 11,52 divided by the sine of 37,52. Close the bracket. 11,52 divided by the sine of the 7,52 is equals to, according to my calculator here, correct to two decimal places, it will be 18,9292 units. So MP is equal to 18,92 units. Check your sides. This side is 15. This one we said it's 11. This one is 18. Which one is the largest? The hypotenuse. 18, because it is the largest side in a right-angled triangle. These are called two-dimensional problems. Great learners, at the end of the year, every time you'll get a question, a problem involving the trig ratios, a 2D problem, two-dimensional problem. And this is the approach of how we go about in solving them. They differ from, in terms of level of difficulty, they differ. Check the first one that we did, check the second one that we did. Both cases, they are different from the previous ones. I'm sure I'm going to leave you with lots and lots of activities to practice the skill on these 2D problems. On that note, let's do one last problem before we leave, one last problem on 2D before we end the session. The last one. It reads an aeroplane at point A. The aeroplane at point J, an aeroplane at point J is flying directly over point D. Is flying directly over point D on the ground. At a height of 5 kilometers. High. It is landing to land at point K. That aeroplane is landing at point K. At K. At point K. The angle of depression. Remember at the beginning of the session, I talked of the angle of depression and the angle of elevation. Be able to differentiate between the two. The statement reads, the angle of depression from J to K. The angle of depression from J to K is 8 degrees Celsius. Is 8 degrees. I'm sorry. The angle of depression from J to K is 8 degrees. S is a point along the road from D to K. Then they say S is a point along the route from D to K. Thank you. Diagrammatically, they said they have a diagram like this. They say here J, remember we said an aeroplane flying at J. Here is an aeroplane at this point. Then we've got GK here at the horizontal surface. It's point D, K. And the angle of depression from here goes down to point S, K. And remember, because we talk of the angle of depression, if we talk of angle of depression from here to there, so that angle is 8 degrees. Depression, you look down, that angle is 8 degrees. They said JD, that height, is at the height of 5 meters. An aeroplane at J is flying directly over a point D on the ground at a height of 5 kilometers. JD, this will be a height. If it's a height of 90 degrees, this side would then be 5 kilometers. 5 kilometers. Because this is an angle of depression, this line will automatically be parallel to that one. Trying to represent the information written here on the diagram. And then let's answer the following questions. The first question reads, the first question, thank you. Write down the size of angle JKD. JKD. Write down the size of that is the question. We need to write down the size of JKD. Look at the diagram. JKD. This still not. Write down that angle. Remember, this side is parallel to this one. From Euclidean geometry, if you have two lines that are parallel to each other, then the alternate angles will be equal. So to answer the question, we'll say JKD, that angle here, the JKD is equals to 8 degrees. You don't have to provide a reason, but because at the moment we are still learning, let me give you the reason so that it should make more sense. You've got DK that is parallel to this line here. So because you've got the parallel lines, the alternate angles will be equals. The two, those are the alternate angles, where we have that line in J parallel to DK, parallel to DK. So the first question has been answered. The information that was in there, you as a grade 10 learner know that we have parallel lines. Once we have two lines that are parallel to each other, the alternate angles will be equal. So angle JKD is 8 degrees. The second question. Calculate the distance DK. Calculate the distance DK. Let's work out DK. Remember, of utmost importance is to keep on updating your diagram as you solve these problems. Once you have KS8, write it down. Keep on updating your diagram. So K is 80 degrees. Now they want to calculate the distance DK. Calculate the distance DK. In this right angle triangle JDK, you have this angle. So this side is reference to angle K. You have JD as the opposite side. The question wanted to calculate DK with respect to angle K. This becomes the adjacent side. So you have the opposite here, you've got the adjacent. Think of a trig ratio that will involve 8 degrees, the opposite side, and DK. And that trig ratio will be a tangent. Then we say the tangent of 8 degrees in triangle JDK. The tangent of 8 will be 5 over DK. Will be 5 over DK. Now you work out the length of DK, multiply by LCD, it will be DK, and then divide by the tangent of 8. Therefore, DK will be equals to 5 divided by the tangent of 8 degrees. Take out your calculator, work out 5 divided by the tangent of 8. Thank you. 5 divides tan 80 degrees. Equality side. 35,58. 5,58 correct to 2 decimal places. Tangent divide 5 divided by tan 8. It's going to give you 35,58. Correct to 2 decimals, no decrease. The length will be 35,58 units. Thank you. That will be an answer to question 3, where we to question 2, where we expected to calculate the length of DK. Thank you. Let's proceed. Now we have this side here, it's 5. This side is given as that we have calculated with 35. DK is 35. Please make sure with your calculation, it's 5 divided by 5, you divide by the tangent of 8. The tangent of 8. 5 divided by tangent of 8. I need to verify. Close the bracket. It's 35,5758. Correct to 2 decimals. 35,58. Perfect. Now, the third question. If the distance SK is 8 kilometers, where is SK? SK is 8. They give you SK is S8. Remember the whole length here, DK, is 35.58. It is this whole length, DK, is 35.8. 0.58. So they say SK alone is 8. If SK calculate DS, calculate DS. If SK is 8, calculate DS. How are we going to calculate that? Remember, the whole length is 35.58. This alone is 8. Therefore, DS, to calculate DS will be 35.58 minus 8 units. Then the answer will be, let's take out our calculator, determine the difference. 35.58 minus 8. Then you are left with 27.58. 27.58. You are left with 27.58. The last one, calculate the angle of elevation from S to J. From S to J. From S to J. They want you to calculate this angle. Elevation. If you had S, you go up. This is the angle of elevation. From S to J. They want us to work out that angle. Remember, we said this side is 27. 27.58. Because this one is 8. You add them together, they will give you 35.58. Let's check. This is the last one. The question wants us to determine, the last question, I'm sorry, calculate the angle of elevation from point S to J. Calculate the angle of elevation from S to J. I said from S here, look at J. Angle of elevation, you go up. So this is the angle. This is the angle. Angle JSD. Let's work it out here. We have this side as the opposite side. We have this side as the adjacent. So think of a trig ratio that has got opposite and adjacent. So we say it will be tangent. The tangent of JSD, this angle here, is opposite over adjacent, is equals to 5 over 27.58. Therefore, now you take your calculator, you work out the size. JSD, remember, if you calculate an angle, there is a shift button. Ensure that your calculator is switched to a degree mode. Then now, to calculate the angle, there is a shift button. Shift tangent. Then you write down the fraction. 5 over 27.58. Thank you. The tangent, first the shift, and once you enter the shift and then you see tangent, you'll see exponent -1 there. Then you write 5 over 27.58 equality side. Then you've got your answer there as 10.28. 10.28 degrees. This angle here will then be 10.28 degrees. So we have answered all the questions. The first question wanted to write down the size of JKD, because this line is parallel to this one. Alternate angles are equal. We answered that one. From there, they wanted us to call the length of DK. We had this side, we have this angle. Think of a trig ratio that has this angle and that side, and DK k as a side, then that trig ratio became tangent. And if you use tangent, you've got dk is equal to 35.58. So dk is 35.58. Now for problem number 3, they give you sk as 8. This alone is 8. So to get ds, you need to subtract from 35.58, you need to subtract 8. You end up with 27.58. Now that you have this one, the last angle wanted you to calculate this angle, JSD. Think of a trig ratio that involves the known sides. We have this side, we have this side. With respect to angle S here, this is opposite, this is adjacent. So opposite over adjacent will lead to tan. Tangent JSD will be 5 over 27.58. Take your calculator, shift tan. You will see the exponent will be -1. Then the equality sign. Then you've got your angle as 10.28 degrees. Great, learners. Thank you very much. We have come to the end of the session. The session on which we were discussing two-dimensional problems. Two-dimensional math is commonly known as the 2D problems, D for dimensional. And I said at the beginning of the session, the most important things that you should know: angle of elevation and angle of depression. Know how to identify the angle of elevation, look up; angle of depression, you look down. And then we went on to say, know your trig ratios, sine, cos, tangent, including their reciprocal identities. Know their ratios and master your calculator, because without the aid of a calculator, it's impossible for us to solve these activities. We have come to the end of the session. I hope that this lesson will help you a lot in the end of the year examination. From me, Mohapi, wish you all the best. I thank you.